Hey, good morning, everyone, and we start now. So let me explain some mathematical detail about the formula which we use in last class, because the corporate students and also Jensen this morning before the class asked the question, but some other students also asked me in private by email or some other way. Ask the same question. Let me explain a little bit about this one. By the way, if you have any difficulty, any problem, please don't hesitate. Just ask me, and I will explain as far and as clearly as I can. So the first one is about. Let me. Explain this one, and a couple of students don't quite understand how to calculate the first order condition. You know, this is the first order condition for this problem. For this problem, we have eight different variables: xa, ya, xb, yb, and Lx, Ly, and Kx, Ky. For each of them, we find the first order condition. And then now let's focus on the first one. Let me explain the step by step in mathematics, how to calculate the first order condition for this variable. And here, if you look at this formula, where we have xa, and here we have, let me. So here we have xa, and here we have xa. Nowhere else. So therefore, we need to calculate the first order derivative for this term with respect of xa or in xa, and this term xa. For this one, should it be partial ua over partial xa? You know, this is the first order effect. Or for increasing for consumption for goods goods X by Alice on the utility, on the welfare of Alice. And mathematically, that's the first order, this one. And then for this term is much easier because this is a linear function. Here is gamma x. So therefore, this one should be partial ua partial xa minus gamma x equals 0. And but then we can shift the whole term from the left to the right. So that's, and then we put this one partial ua over partial xa by uax. This is the lazy, this is the simple way. Otherwise, you know, you can imagine all the formula look very ugly, very complicated. We are lazy, which we simplify the mathematical expression, the formulation. We put it as uax. This for A, the sub-index is for the person Alice. This one, the super one, the subscript is for the goods X. So this is the marginal utility for Alice in goods X equals gamma X. So if you understand this one, I believe you can also, if you go through this formula carefully, you can also understand each of the other 7, roughly the same, all the 7 equations, and we did it in a very similar way. And fortunately, for each of them, we have only 2 places. And to find each of them, xa, ya, xb, yb, and if you look at it carefully, even for the resources, For example, if you look at where we have X, we have only 2 places where we can find it. So therefore, the calculation for first order condition become much simpler. So this is the one point I needed to explain again. So now, okay, now let's continue our discussing. By this is the mathematical way of deriving the so-called 3-level optimal condition. On the exchange level, I put it in the green color, we get this one. On the production level, we get this one. It's all about how to make use of resources, labor and capital, in organizing our social production, producing X and Y. This is about how to organize production, and then we get the production optimal condition. So this part, let me write some simple English words to help you understand. So this part is about production. It's technical stuff, nothing to do with economics. It's more about engineering and technology. It's about technology. Or sometimes we call this technical efficiency, or sometimes we call this productive. Sorry, it's pretty hard to write. Productive. Basically, what's happening in production? This is so-called either technical or productive. So hard to write. So this is about the technical dimension of our story, how to organize the production. This is a typical problem faced not by economists. It's rather faced by the engineers, the people who are doing the business for producing, for production. And so therefore, this part is not about the so-called sorry, this one should be B. This is a small mistake. There's a marginal rate substitution for Alice and marginal rate substitution for Bob between X and Y. This one is different. The economically speaking, the story we are telling by this equation is completely different from this one. This one is sometimes we call this about you and me, how we as individual human being feel about good X and good Y, banana and apple. Okay, how good a banana is compared to an apple. This is about our subjective feeling, 主观感受. Okay, this is about objective, 客观. Okay, this is about very subjective, who we are, how we feel in psychology. And so therefore, this is about the human being. This is about the material. And now, one point I should mention is that when we talk about production optimum, what's the economic meaning of that? The economic meaning is don't waste any resource, no waste, please. So in other words, we should produce as much for the goods X and Y as we can. And if this condition is not true, then sorry, we have discussed and explained in last class, we can always reallocate labor or capital in a way to increase the output X and Y. Do you remember in last class, we give a very simple example about how to reallocate labor to produce more X or more Y if this one is not true. And so therefore, the so-called production optimum is basically means technical efficiency or productive efficiency. That is, we have organized our social production or our technical part of our life in a way that we don't waste anything. So, and we will shortly introduce the idea of PPF, which I believe everybody is familiar with, but we will do it again. We will introduce the idea. And when we introduce the PPF, I believe you will have a better understanding of the so-called production optimum. And now, so let's go on. Before we go, let me. Okay, and so this is one more point I would like to make about the production optimum. This basically means technical efficiency. We organize our, how to make use of the material, labor, and capital to do things, to produce as much as we can. And so therefore, this part has not so much economics, not so much economic content. And now let's bring together the two parts. We organize exchange in a good way, organize production in a good way, and then we put them together. We claim we got a top level. And here, one student, Fanny, just asked me to give a little bit more explanation about this one. I will do that. I believe some other students may have a similar problem about this one, particularly the difference between the two numbers. And so here, and mathematically, we can easily get this result. You just play around with the 8 first order equation. Sometimes you combine these two equations is all about X. Sometimes you have to put together different products X and Y. And in doing so, you can get something important, that is how to produce more Y by producing less X. If you focus on this equation, and what's the economic meaning for this one? And forget about the mathematics. Just focus on how to understand this equation. Again, let me explain a little bit further. And what's the meaning for this one? The meaning for this one equals, let me put here, partial Y over partial L. So this is the marginal productivity in producing Y of a labor. If you have one more worker, how much Y we can produce? And this is the numerator. The denominator, this part, XL, is marginal productivity of X. Sorry, over partial L. So now, how to understand the meaning of the whole thing, the whole term? So this is if we have one more labor to produce Y, how much Y we can produce? That is, roughly speaking, change in Y by changing labor input or for producing Y. And similarly, this one is the change in X. Okay. And now the prompt is, if we increase, so here I should mention it should be Ly, should be Lx. We increase the labor input in the production for Y, how much more Y we can produce. And you know, the total labor resource is given, is fixed. So therefore, when we increase Ly, we have to decrease Lx. And by exactly the same amount, the same quantity. If we increase Ly by 1, we have to decrease Lx also by 1. If we increase by half, then this one also decreases by half. And now, to keep that in mind, we can get a very clear understanding of this term. That is, if we increase Ly by 1, decrease Lx also by 1, okay? And then we can produce more Y. At the same time, we must produce less X. So therefore, if this one is positive, this term must be negative. Okay. We can produce more Y only if we produce less X. Otherwise, how can we find such resources? We have to reallocate some resource from X, producing X, to producing Y. That's the only way we can do. So therefore, if one number is positive, another number must be negative. So therefore, actually this one, you know, this one, the numerator and the denominator are always positive, but this one is, if this positive, this negative, then it should be equal to this one. But sometimes we are too lazy to care about, you know, is it positivity or negativity for the value for this one. And now, forget about mathematics. Let's come home, understanding the meaning for this one in economics. What does that mean? That means if we give up some X, how much Y we can gain, we can get. So in other words, if we increase X by 1, how many Y we can get? This is marginal rate for transformation. Okay. As if here, let me explain the T. T is transformation, as if we are transform apple into banana. Okay. And oh, it's too difficult. Let me put it in simple way. This is transformation. Transformation means by using less resource on X, more resource on Y, then we produce less X and more Y. As if here, that's the keyword as if we are directly transform some X into Y. So therefore, we call this a kind of marginal rate of substitution. But in the technical sense, or we just call marginal rate of transformation. Whatever you call, the meaning is this is about the production technology. This is about the so-called objective part of the technical part. So therefore, this one is about technology, but this one is about subjective. Again, let me explain before. Any question? No. This again, this is so difficult to write. It's about, again, subjective things about you and me, how we feel as a human being, as a person, how we feel about whether the apple or banana are more lovely. And it's so difficult. And this one is technical, or sometimes you can understand is objective. And in Chinese, sometimes we call this one is 主观, this one is 客观. So so-called subjective means basically means, sorry, it's so hard to write it. So now we put the two things together. One part of the story is about the subjective, but not about the objective. And then we got to the top level. So this is the so-called top level optimal condition. So Fanny, are you okay now, or you still have trouble understanding this term? Okay, good. So let's. So any other students have still have some problem, or okay? If no, let's go ahead. Let's go to next topic. And if you have any problem, we can have a much better communication now. And just let me know. Okay, I should. Okay, and now let me share with you the following two figures. I love the two figures. When I prepare this, and so I'm a little bit excited again about the two figures. I really love the two figures because from such a childish figure, we can learn very, very much, and even somehow deeper in economics. Let me share with the first one. And for this one, I hope after this class, you will keep this figure in your mind for a while. But this figure tells us a lot of things about what we economists, we stupid economists, can understand the economy. And now, let me start from this golden equation. There's some economists like a joke about what we know in economics. This is the golden equation. Why is it golden? Because this equation brings together two things. This is about human being, subjective, how we evaluate the relative importance of apple and banana. This is about engineering. This is about technology. This is about technical stuff. Given the technology, how much X and Y we can produce. And if we organize the social and economic activity ranging from resources to the end, the happiness for making the micro people, we should do it in such a way. And now let's try to understand it from economic perspective. Here we will do it by two different ways. So the first one is let's focus on the so-called representative individual or a sort of social marginal rate substitution. This one means we can take one person, one individual. That person, that guy can be representative of the whole society. Or to simplify our discussion, you just imagine here, let's consider a society. Alice and Bob, exactly the same. They have the same preference. We call that homogeneous population. And let me emphasize these keywords. Homogeneous population, all the people exactly the same. And later on, I will give you the second discussion by using idea, the heterogeneous population, if the people are different. And now, let's focus on this one. If we find all the people are the same, we introduce this assumption to simplify the economic discussion. And then we can understand this one very intuitively, even if then we know nothing about mathematics, but we are very good economists. We can also directly get this equation. How to do that? So let me explain how to do it. We introduce two economic arguments, two economic reasoning, economic analysis to understand why we can easily get this one. The first reasoning is by using the typical marginal substitution argument. Here, for the consumers, the representative consumer, individual, can substitute X by Y, and then turn to the production technology, we can also substitute X by Y. So that is producing less X. At the same time, we have more resource to produce Y. So therefore, we can produce more Y. And how to understand this equation? And from economic perspective, here let me emphasize, we are economists. We suppose we are idiot in mathematics. We're just idiot. We are very stupid in mathematics, but we are brilliant in economics. Then what can we do? You just imagine if this is not true. Suppose this term is not the same as this term, not equal to this term. For example, suppose this number is larger, equals 3, this number is smaller. You can imagine if this one is smaller than this one, all the argument just slightly modified, this is still okay. And then what can we see about it? What's the economic meaning for this one? And what's the economic meaning for this one? This one, let's start from this one. This one means delta Y over delta X in production roughly equal to. So therefore, this one means 1X equivalent to 2Y. What does that mean? That means we can produce one more X. At the same time, we must produce 2 less Y. We increase X by 1, decrease y by 2. So that's what we can do about the production. Okay, this is the meaning of a marginal rate of substitution between x and y in technical science, or marginal rate of transformation, whatever you interpret it, that doesn't matter. What matters is this is the change rate, the rate of a change between x and y. We turn one x into 2y. That's the meaning. And what's this one? This one means in terms of consumption, 1x is equivalent to 3y. Then now we have a wonderful way to have a better life. And now we can produce one more x and 2 less y. This is just by the definition from MIT. This is about MRT. This is about production technology. We can do that. And then after the production for the consumer will have 1 more x and 2 less y. For the consumers, 1 more x and 2 less y. Okay, because we produce 1 more x and 2 less y. But now the increase in x is equivalent to 3y, 3 units in y. So therefore, for the consumer, effectively, she had 3 more y and 2 less y. So therefore, altogether, the consumption in y increased by 1. At the same time, the consumption x doesn't change. Remember, here we increase 1x. This increase in x is equivalent to 3 increase 3 in y. At the same time, by producing 2 more y, we produce, here. We produce 1 less x. So that means minus 2x. So altogether still 1 more y. So therefore, the welfare increase and so I should be okay, so that's okay. And here, in doing so, we can increase the consumer supply, the consumer welfare, and exactly in the same degree, to the same extent, by increasing the consumption y by 1 unit. Okay, so therefore, that means if this one is not true, we can do a better job. So therefore, if we have done good job, this one must be true. Okay, now let me try to get some feedback from you guys. Anybody had difficulty following this argument? We have already made use of such argument a couple of times. Such very simple numbers and try to understand the rather general equation, general condition. Do you have any difficulty understanding this one? No? Any problem? If no, let's move forward. And so this is a very simple way, a little bit childish, but this is a very powerful way for understanding this equation. That's based on economic argument. Okay, this is one way. Just make a good use. economically good user for the mean from marginal substitution. We can substitute x by y or y by x at the same in both consumption and production. And if this one is not true, we can do a better job by changing the resource allocation. So and now another way to understand is also quite childish, but really straightforward. Again, this one, the idea is, let's turn back to the general picture. What we are doing? What we are doing here? We are organizing resources. Okay, we have a lot of different sources: labor, capital, energy, water, so on and so forth, to do a lot of stupid things. Organizing production, exchange, for what? We are doing for this. We are doing all the things for the people. Basically, we are turning resources into happiness, into welfare, by going through the complicated social process. Okay, so therefore, our single job is turning resources into good life, and this is the general picture we are now facing. And okay, how to do it in a smart way? The smart way is the golden equation must be true. How to understand that one in economics? You know, this is the marginal condition, and this one is, sorry, no, oh. This one is the same as this one. This is the marginal rate substitution, subjective for the consumer, individual consumer, marginal utility X, marginal utility for Y. And this is how the consumer feel about the relative importance of for goods X and goods Y. This part is about the technology, about the production technology. We produce as much as we can. We call this production, possibility frontier. And if we change X, we have to change Y. This is the ratio between the two changes. We bring together the two terms. And now, that's a key point. We can reorganize this equation. Just be careful. This equation is equivalent to this equation. But the difference is by putting this equation, the golden equation, into this way, we get something interesting. What did we get? We get so-called UX, UY, and dy over dx. And now, to simplify the mathematical formulation, we put it together UX times dx, UY times dy. This must be true. Okay, what does this mean? This one means we can either produce a little bit more X, that's small change in product X, if we reorganize our social production in a way to increase X a little bit. If we do it, eventually we put the more X into the hand for the consumer. Then this is the change in X. This is marginal utility of X. So therefore, if we produce more X, we can produce more utility, produce more welfare, produce more happiness for the people, for you and me, for the mechanism people, for everybody. So remember, here we are talking about the representative individual. We are all the same. So therefore, we can randomly take anybody from the street, from our society. Let's focus on that guy. If we increase dx, that person's utility will increase by this much. You know, the meaning for UX is how much your welfare increase if you consume one more X. And then now you consume this much more. So therefore, your utility will increase by this number. At the same time, we can also produce a little bit more Y and then put the more Y into the hand for consumers. And the same consumer utility will increase by this much. And now, this equation tells us the two numbers must be the same. How to understand this one in a very simple way, in actually very powerful way, but we call it a childish way to be modest. And that is, we are using resources, either produce X or produce Y. If we produce X, we can increase the utility deriving from X, or if produce Y, we can increase utility deriving from consumption for Y. So therefore, the general picture we are now facing is how to organize everything to make good use of resources in order to produce utility or welfare or good life quality, happiness, whatever you like to call. Basically, what we are doing is turning this one, resources into utility, into happiness. We must do it in such a way. The idea is if the two number is not equal. Okay, suppose again, this number equals 3. This number equal 2. Then what should we do about it? We should produce one little bit more X. Okay, and then we consume a little bit more X. Then our happiness, our utility will increase by 3. Okay, and we can produce a little bit less Y. This number, if this number is positive, this number must be negative. Because given the resources, to produce more X, you have to produce less Y. So therefore, we can produce a little bit more X, at the same time, a little bit Y. To produce more X, our utility increased by 3. To produce less Y, our utility decreased by 2. Altogether, that's beautiful. Our utility increased by 1. So that means if this equation is not true, or this equation is not true, or this equation is not true, we are stupid. We can do a better job. We should produce more X and less Y. Then we can have a better life. So this is the economic meaning for this equation. Right? This is another way to understand why the subjective marginal rate substitution must be same as the objective marginal rate substitution. Okay, and now let me bring you back to the general picture we are facing. As I mentioned earlier, this is the problem we are facing. We are turning resources into happiness or into welfare. we just, generally speaking, forget about liberal, capital, whatever. You just call R, that's resources. Whatever resources, we can produce X, we can produce Y. And why do we do that? We produce X in order to increase utility. We produce more Y in order to produce utility. So therefore, now the picture, just focus on the blue color, okay? The blue color one. We are producing happiness by using our resources. So therefore, we must do it in the way that golden equation is correct, is true, okay? So how to do that? The R can go this way, the R can go this way. So in both ways, or for using R, using resources, the result, the effect must be the same, okay? If we are going this way, we are taking this way, we can have a better effect than going this way. We should put more resource on this channel, less resource on this channel. It's quite straightforward, right? Quite a simple, very, very simple argument. So therefore, if we have already, at optimal, we should find wherever you put a resource must be give you the same effect. Otherwise, give more resources to the channel which give you a bigger number, and less resource to the channel which give you a smaller number until they are equal to each other. So if this one is larger, this way, or this way, whatever, is larger than another, give more resources to this channel, less to this channel, and then the utility will increase. That's this. This is very childish way. If we have a normal teaching model in classroom, I can, we can have a much better discussion. Then the whole idea is quite clear, quite economically sensible, and also it will be make you feel much more comfortable in understanding the mathematics. Mathematics just help us to confirm what we know in economics. Okay, now let's turn back to this. Okay, now, and in English, 1,000 words is less effective than one figure. And in Chinese, we call 千言万语不如一幅画. Okay, let's try to learn from the kids. The kids, every kid is a genius in drawing picture. Now let's try to take the kids that our teachers had. And let's train all the argument, either this way, the so-called typical margin substitution, whatever. Another one is train resources into happiness, whatever. Let's forget about it. Let's have a probably even better, even more intuitive, even much smarter way of understanding the picture. This is, again, we are assuming all the people in Macau City exactly the same. Clearly, that's not true. But now, for the moment, just for discussing, let's assume we are the same. And in next page, we will relax this condition. We just consider the different people. But now, let's simplify the picture. Again, everybody is the same. That's you or me. There's no difference, and we are the same. That's an independent curve for everybody, or for the society. This is stand for the left side of this equation. That's about subjective, about us as a human being. how we feel about apple and compared to banana. That's about human being as a kind of animal. It's about to have some subjective feeling. And this one is about the stupid things. It's about technology, about the production. And this is so-called PPF. If we produce more X, we must produce less Y. So therefore, this curve is going down. The inside is the feasible set. We can produce, for example, any point inside. Here, for example, clearly we can produce this much. But if we produce this much, we have not yet got the production optimal. The production optimal means we should always operate on this curve to produce as much as we can. So therefore, you can see we have so many production optimal solutions. The so-called possibility. What is possible to produce? The frontier means the maximal output of X and Y. So altogether, this is a curve. And this curve is not necessarily concave, but here we draw the curve as concave, just for discussing. Okay. And then the marginal rate, for example, if you draw the tangent line at this point along the curve, the slope is, or for this straight line, the tangent line will be the marginal rate of transformation. Basically, marginal rate of substitution in technical sense. And then what's the top level optimum? The top level optimum tell us the marginal rate of substitution, the subjective marginal rate of substitution for the consumers at this point must be the same as marginal rate of transformation at this point. And so therefore we can draw a curve. And why? You can imagine for such production technology, suppose we macro people, our technology is only such. We can produce wherever you like along the curve. Which point is good, is the best one. And we can draw the curve. We have such an independent curve. Okay. Clearly, we can produce this much and then put it into the hand for the consumer or for the market people. Then the market people's welfare or utility will be on this level. Or we produce this much. Produce here means we are already getting the production optimal. Sorry, here we production optimal. And here means we have not yet achieved anything. Okay, because we have not yet achieved the production optimal. And at this point, we indeed achieve production optimal, but it's not top level optimal because we can change the production plan to this point. And again, up, produce more and more Y, less and less X. Eventually, at this point, we can't make an even better job because for any high level for utility, for example, this one, we can't achieve it. It's not feasible. Given the constraint of production technology, we can't do it. We know it's good life, it's better life, but that's not us. Okay, probably some other countries, they're lucky girl or boy, they can have such a good life, but we can't. So therefore, given such a constraint, where we can go at best. This is where we can go. And what happened at this point? The two curves share the same slope. This is marginal rate. It's the same. Okay. So therefore, I hope this curve can help you understand why at optimal, if the people are exactly the same, then this equation must be true. This equation just tells us the two curves are tangent, and then the slope, the slope of the tangent line is the common marginal rate substitution. So let me again try to just double check if everybody can follow the argument. Is okay? Okay. If no feedback, I suppose you buy my argument and you agree with everything I just said. So therefore here we simplify the discussion. Again, let's emphasize this just for better understanding, clear picture in economics. Here we make a strong assumption. This is really strong. We assume we can find such wonderful person. This wonderful person can represent our society for the whole Macau society. Like, what does that mean? We are the same. Okay, so therefore that guy's preference is also the preference for everybody. And then based on this strong assumption, we offer such argument. Okay, I hope everybody can go through this page after class just to have a better understanding. This argument, either the two ways, either this one or this one is quite simple. It's also actually quite powerful to help you better understand this one. And now let's come back to reality. We are not the same. We are quite different, actually. You are you. We are just everybody different. Then what happened? This is the general picture. And suppose we are different. But eventually, if we go to the top level optimal, everybody, each I, here, the keyword is any. We can focus on any, you or me, Alice, Bob, David, Frank, or everybody. We just randomly take any person in the street from Macau City. That person's marginal rate substitution must be that objective for anybody. That number must be the same as the stupid marginal rate. That is marginal rate for a substitution in a technical sense. This is in producing, this is in consuming by anybody. The exchange optimal condition means this number must be the same for I and J, for any individual I and individual J, Alice and Bob. They share the same marginal rate substitution. That is exchange optimal. And then to bring together such marginal rate in consumption with marginal rate in production, we get the social optimal or top level optimal. And now, how to understand this equation in a picture, in a figure? Here it is. And for the moment, forget about the different consumer story. We focus on the stupid part of it. The stupid part is how to produce. That's the job done by the engineers. How to produce. And given this PPF is the same as in last picture. This curve, okay, is about the production. It's about what's possible can be produced. Okay, what's possibly being possibly produced this curve. So this curve is about production. And we can operate in organizing social production any point along this curve. For example, if we organize, let me draw something. Okay, if we organize our production at this point, that is, we produce this much X and this much for Y. Okay, and then focus on this one. Let's call this X1, this Y1. Y1. Focus on this square. This one is the box. This one is, oh, sorry, I have already got it. So this is Edwards box. You know, when we discuss exchange optimal, we are basically focused on this box. Okay, forget about this one and this one and PPF. Just focus on this box. This is exchange story. Okay, so therefore, if we producing X1 or for X, Y1 or for Y, then we consider how to divide X1 between Alice and Bob. Okay, this is Alice, this is Bob. So therefore, when we discuss exchange optimal, we are basically focus on one part of the whole story. We fix the production plan. It's already done, okay? And don't consider again. And then for this Edwards box, we can draw the so-called Pareto set. And on each point, let me again try to draw something for you, just for discussing. For example, at this moment, probably we can draw, oh, sorry, this for Alice and another for Bob. And then they share the same marginal rate substitution. So therefore, this point is one exchange optimal solution. And also here, we have another one, exchange optimal. So something like this, and you know, the curve is difficult to draw. Sorry, this is the straight line. And now we collect all such good points for the exchange economy, X1 and Y1 together. We got this curve. This curve stands for all such exchange optimal solution for this Edwards box. And among them, each had kind of a marginal rate substitution. At each point, Alice and Bob, they have the same marginal rate substitution. That is exchange optimal. Among such exchange optimal, usually only one point is such that this marginal rate substitution equals this marginal rate of transformation. This one is marginal rate of transformation. This one is marginal rate of substitution. So the economic meaning of this one is very different from this one. This is about, again, subjective. This one is about objective. So usually among the whole curve, we have only one point such that at this point, the marginal rate substitution equal to this one. Okay, so this is the top level optimal. This is one top level optimal solution. And let me summarize further discussing on the box. Among the box, each point along this curve is exchange optimal. This one is production optimal. When we put the production optimal and exchange optimal together, then we will find only this point satisfies the top level optimal, because at this point, the two numbers are the same, this number and this number. And now, let's consider another point. For example, here I just focus on another one, just a little bit further away from this one, just for our discussion. For example, we can also produce this much. X2, we can produce more Y and less X. And then for this one, again, we consider exchange story. We have organized the production. We produce this much X, this much Y, and then the problem is how to allocate X and Y between Alice and Bob. Again, for this AdWords box, we can draw the exchange optimal curve, we call Pareto curve. And usually among them, only one optimal exchange optimal is such that, again, this is the marginal rate of substitution. This is the stupid thing about the technology stuff. Marginal rate of it's so hard. Usually we have only one point among such a curve, such that this slope is the same as this slope. They are the same. So now, if you focus on this figure, we can tell a lot of stories. The so-called production optimal is PPF. PPF is production optimal. Optimal is the tautology of PPF. Operate production along the PPF, we get the production optimal. Exchange optimal is for any given point along the PPF, we can draw the box. Then we can draw the figure. This is exchange optimal. And the top level means we must consider simultaneously. At the same time, we consider both production and consumption. So therefore, at this point, we get this one. Somehow they match with each other. They're consistent with each other. In the way, this number is the same as this number. Once the production is fixed, this number is given, is fixed. Among such exchange optimal, we must find such a point which match the given number. This is true for any point along the PPF. For each one, we consider the same problem. What's the social level or top level optimal? So now you can see this point together with this point. That's one good way of a Pareto optimal. This one plus this one as another one. So therefore, you can, in general, you can easily understand. You can easily understand this sentence. Optimal for exchange economy, we usually routinely have multiple, so in general, optimal for exchange economy is usually have multiple solutions. So therefore, this one, each point is a good solution, we have multiple. And the top level solution for whole economy also have a very big number of solutions. This point is, and also, as mentioned earlier, this point is also another one. For each point along the GPF, we can find a good solution. And then, fortunately, when we introduce social wave function, do you remember at the very beginning, we spent much time discussing the different social wave functions. That's about our value judgment, how we believe which way of life is good life. That's about our social kind of the ethical judgment, about value judgment, about the social welfare. And if we introduce such a kind of philosophy, such a kind of criterion, such kind of social wave function, then usually among such many solutions, we can only one good solution, one point. That point will be determined both social production and social consumption. And next class, and we will look at two examples. So next class, we will just do some simple exercise. We spend the whole class on two examples about, we have discussed a lot of theory, a lot of concepts. We also draw a lot of figures, but we have not yet got time to give an example. We will give an example to understand what's going on in the box about exchange optimal and what's going on for the whole picture. That's what we're going to do in next class. Before you go, any question, any feedback? Let me know. Do you have any question to ask or anything, or any point you would like me to spend several minutes in next class to explain, to make more discussion? And fortunately, we have a much better Zoom teaching quality today. The technology didn't make trouble to us. Okay, any question or any feedback? Any comment? No? If no question, you can go now. It's we are surprised to conclude 15 minutes before 1 o'clock, I think. Just give you some time for lunch and or for another class. Okay, let me give you 2 more minutes to, just in case you have question or have some feedback, some comments you want to make. Any question or?
Professor, can you hear me?
Yeah, sure.
Okay. So I would like to ask a question, like on reasoning 1.
Okay, reasoning about, okay.
About reasoning 1, you mentioned that marginal rate substitution for x, y equals 3, right?
Okay, yeah.
Equals 3, and you mentioned that 1 more x and 3 more y.
Yeah.
But I think the marginal rate substitution is like 1 more x and 3 less y.
Okay.
Yeah, so 3 less y, and so
yeah,
the final result is not the welfare increased by an amount due to an increase in y by
yeah,
1 unit.
Yeah, I get your point.
Okay, thank you.
I know what you mean. What your problem is.
Yeah.
Here you must be careful.
Okay.
And I get your point, I think, clearly. And when we talk about marginal rate, this we have some constraint given by the technology. Okay, when we produce more X, we have to produce less Y. And when we consider marginal rate substitution, we have different constraint. That is, we don't have to be constrained by the given utility. You know, we get this result by fix the utility, right? So if we still just moving along the given indifference curve, what you said is correct. You know, we can either increase x and at the same time decrease y, or increase y at the same time decrease x, then our utility doesn't change, right? But here, the meaning for this one, marginal rate substitution of between x and y equals 3, you can also understand differently. Don't be constrained by the given indifference curve. So that's a key point. What's the meaning? The meaning is 1x is equivalent to 3y. What does that mean? That is, if you consume one more apple, okay, is equivalent to consuming 3 bananas. Do you hear me?
Oh, yes. Oh, I got it. I got it.
Okay.
Like 1x equals 3y. Like
right.
that.
Right.
Okay, okay.
So therefore, if you consume, you have one more apple. That means you have 3 more bananas. At the same time, by this constraint, you have 2 less bananas.
Yes, yes.
On the one hand, you have 3 more effectively. And in the real life, you have 2 less bananas. So therefore, you have 1 more banana. That's a key point. I can fully understand your concern. And that's about how to understand this term.
Okay.
You agree?
Okay, I got it. I got it.
Okay,
Thank
good.
you. Thank you.
Any other, probably some other students also have the same question. But this one is if you understand this one, it will be very helpful for your understanding the whole picture. And let me turn to other students. Okay, we are running for time. We're really running for time. I should conclude now. Okay, thank you. See you on Friday. Every Friday is a very bad day, and hopefully the coming Friday is different. I believe I should be. Now I can put everything under control almost. My computer is old, but working well and working better now. Okay. Okay, thank you. Bye-bye.